So welcome students. Today's topic is titration. What is titration? As I already told you, titration is experiment performed to know the unknown concentration. To know the unknown concentration. By treating it against a solution of known concentration. By treating it against a solution of known concentration. Okay? So we will do titration today of sodium carbonate. Concentration of sodium carbonate is known. Concentration of HCl you don't know. Means how much HCl I have added in 1 liter of water. So by performing titration, we will know the concentration of HCl. And similarly, we can do like that. Concentration of HCl is known and concentration of sodium carbonate solution you don't know. When you do this titration, you can calculate. Concentration means molarity, number of moles per liter. We will calculate molarity, then strength is asked, and then percentage purity. In plus 2 level, same will be asked. Okay? So, titration that we will do is simple acid-base titration. It is simple acid-base titration, and the titration we do today is sodium carbonate and Na2CO3 versus HCl aqueous, both are solution. Okay. Versus HCl titration we will do today. Okay. And which one is acid, which one is base? We know HCl is an acid, but HCl is a strong acid. Okay? We have studied in 10th standard strong acid, weak acids. It is a strong acid. And carbonate, this is your weak base. Because we are taking a weak base, so indicator is used. Okay? To know the end point means when we have to stop adding the solution from burette. Okay? So weak base, for every weak base almost we use methyl orange. This is our indicator, methyl orange. Okay? So for weak base, indicator is used. Indicator is used, that is methyl orange. Methyl orange. And another titration that we can do, this is in plus 2 standard also, titration of NaOH versus oxalic acid. Next titration that we can do, and this is in plus 2 standard also, this is titration of NaOH versus oxalic acid. NaOH is strong base and oxalic acid is weak acid. So again we are having weak acid here. In case of weak acid, the indicator used is phenolphthalein. Okay? You will know when we do that. For weak base, phenolphthalein is the indicator. For weak base is methyl orange. For weak acid, phenolphthalein is indicator. Okay. So note down this much. Next. Next is the procedure, and first of all, let me introduce to you. This tube is called as burette. Okay, it has labeling. Okay, this is burette. This is called as titration flask. Okay, titration flask. You know these are beakers. Okay, this is your funnel and pipette. We are using 20 ml pipette. You can use 10 ml also. So these are the apparatus that we will use. Now, what actually we can do? What should be filled in burette? So I will make this burette. It has a stopper and it has markings. Okay. So you can take any solution in burette. Okay. Generally we take HCl. Okay. When you take HCl in conical flask, in titration flask, you have to add sodium carbonate solution. What is the pipette is given to you? 20 ml. The volume of pipette, so you have to add 20 ml sodium carbonate, and what you have to add? Plus indicator. Okay, methyl orange. So that you have to add into the titration flask, and you have to fill the burette till 0 with HCl. Now keep adding drop by drop HCl into conical flask or titration flask. Okay. When you add methyl orange, this will turn yellow. When you add all this, this will turn yellow. Then keep on adding drop by drop, and when the color change from yellow to wine red, okay, you can write red. When you will see the color, then we can identify it is wine red, which type of red, or it is pinkish in color. Okay, so you will have red color. Then stop adding immediately. Then stop adding, and when you get this, what you have to do? Note down the reading in burette. Okay, note the reading in. Note the reading in burette. This is simple procedure. Okay. Now, if you take sodium carbonate solution in burette and HCl in conical flask, then one thing will change only. This will become red, and end point will be from red to yellow. Okay. You have to add HCl here, 20 ml. Okay. You have to add indicator. Okay. Then the color becomes red, and your end point will be red to yellow. Use the volumes in calculations, and you will get the molarity, strength, and percentage. Everything can be calculated by that burette reading only. Okay. In question, what is given? Two things are given. As I told you, one concentration is known. Okay. One concentration is known means in question it will be given like 2.65 gram of sodium carbonate is dissolved in 500 ml of water. Okay. And the strength is also given in gram per liter. How much gram of sodium carbonate is there in 1 liter. Strength and concentration of one solution is given. Calculate molarity of HCl, calculate strength of HCl, and calculate percentage purity of HCl. All we can do with one calculation. Okay. So you understood this much? Now calculation part. Okay. Very simple calculation is here. Now calculation here from 3 years, those who are getting 28, 29, 26 also, they did some mistake in calculation. And now you can see calculation is very easy. Very easy. Okay. So first thing that is asked will be molarity of the solution. Okay. So next is your calculations. So I will write what is molarity. M1 MA VA is equal to number of moles of A for acid, so what is molarity? Number of moles per unit volume. I just put this volume from here to here. Got it? So this is MA is the mass of HCl. Okay. We have to calculate this. Okay. If it is not given. Okay. VA is the volume of HCl. From where? This volume is from burette. Okay. The volume you have noted from burette, that will be volume of acid. Got it? MAVA is equal to number of moles of HCl. Next, MB VB is equal to number of moles of B for base, sodium carbonate, Na2CO3. Now we have to use chemical equation, because what we are doing? We are doing acid-base reaction. It is a neutralization reaction. We have done this reaction today. You remember? No, not today. I recorded that video. I will send you on Saturday. Okay? So, what is the reaction? You have done this reaction so many times in previous classes. Acid-base, simple. Carbonate. What carbonates do? Remember? Na2CO3. Make a heading, chemical reaction or chemical equation. Okay? Chemical equation. I will write in short form only. Chemical equation: Na2CO3 plus HCl. Anyone? What should be the reaction? What will be the product? Whenever carbonate is treated, what is formed?
CO2.
Yes. CO2 plus, this is acid base. Whenever acid base react together, what is formed? Salt and water. So plus water is again there. What is the salt?
NaCl.
NaCl. How many moles?
2.
2 Na is there. So we have to balance 2 NaCl, and how much HCl is used? 2. So now what is the use of this equation in our formula? What is the use of this equation? So now I will make MAVA upon MBVB is equal to number of moles of acid. How much? What is the number of moles of acid? according to reaction. Yes. रिएक्शन में कितना मोल एसिड यूज हो रहा है? 2 मोल, 2 upon 1. Okay. Here many students used to do mistake. Okay. They just make MAVA is equal to MDVB. No, you have to use chemical equation here. Okay. That's why we derived this formula from starting, from molarity. Okay. Number of moles in reaction, how many used. So it will become MAVA will be equal to 2 into MBVB. From here, this is mass of base. It will be given in question. Concentration of one solution is known. So this will be given how many liters, how many ml this is dissolved. This will be also given. Okay. Or this will be the volume of pipette. You can write. If this is mass of acid, this will be volume of from burette, I told you, and this will be volume from pipette. Okay. How much you have added for this reaction? That is the main point. Huh? From here, can you calculate molarity of any? If this is given, you can calculate this. Volume, you know, one volume you will get from burette, one volume is from pipette. Pipette is given to you, and one mass is given. So you can calculate molarity of any solution out of acid and base. Got it?
Yes, sir.
Okay. Next is calculation of strength. So molarity is calculated. Okay. So how you will get answer? Molarity is equal to dash 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 molar, x molar. Okay. Suppose you will have x molar. Okay. X molar. Now, next question that is asked in practicals, that is your strength of the solution. If you got the molarity, next two calculations are related to molarity only. Okay. And remember that you have to calculate molarity in 4 decimal position. 4 decimal position. Like 0.0008, like this molar. Okay. Like this you have to calculate 4 decimal position. So next is strength. How to calculate strength? Strength. Very simple formula. Strength of, suppose we are calculating for HCl in this titration. Okay. Strength of HCl will be equal to calculated molarity into relative molecular mass of HCl, and whatever you have the answer, write down that answer, and the unit will be gram per liter. Gram per liter will be the unit. Suppose this is Y. Okay. Gram per liter will be the unit. Next is for the calculation of percentage purity. What you will do for the calculation of percentage purity? Noted down this much? Next is percentage purity. So very simple formula. We have calculated strength. Calculated strength upon given strength. As I told you, strength will be given in question also. Okay. And unit of strength is gram per liter. Remember that. Okay. Calculated strength upon given strength into 100 because it is percentage. Okay. And your answer will be dash dash dash. Suppose it is Z%. Only these three things are asked. Okay. Got it?
Yes, sir.
So are you ready? Now we will perform the practical. I know the concentration of all solutions, but you should calculate the accurate concentration. Okay? Let's start now.